I'm Anil Kumar, and here is question number 8 from the practice test on combination of functions. The question is, calculate f divided by g of x for each of the following pairs of function. State the domain. So important thing is you have to state the domain also. Don't forget about that part, right? So we are given 4 different functions here. You can pause the video, copy these functions, solve, and then look into my suggestions. So whenever we have f divided by g, that means we'll have something in the denominator, and that cannot be 0. So that adds to the restrictions on the domain, right? So the very first one will be you have to divide 105 x cubed by 5x to the power of 4, right? So you can divide this. You get 21 x, you can write x here, right? So that is what you get as the result. And here, as you can see, domain is x belongs to real numbers, but x cannot be equal to 0, right? So that becomes the restriction for this function. For the second function, f divided by g will be x minus 4 divided by 2x squared plus x minus 36, right? So now what you can do here is you can factor the denominator. So we are looking for product of minus 72 and sum of 1, right? So what two numbers could give you 72 as the product and difference of 1. When the numbers are so close, what you can do is you can do square root of 72. So you get a number which, let me see in decimals, 8 something, right? So it means the numbers are 8 and something to get 9. Do you see that? So 8 and 9 are our numbers. So let us factor this separately and then we'll write. So what we have here is 2x squared plus x minus 36. So I'll write this as 2x squared plus 9x minus 8x, correct? 9 times 8 is 72 minus 3x, correct? Combining these two and these two, we can actually, it is, I wrote something wrong, it is 36, yeah, 36, correct? So what we have here is 2x squared plus 9x, we can take x common, let me take x common, yep. So let's take x common, so we get 2x plus 9 and minus we'll take 4 common, so we have 2x plus 9, and so now we can write this as 2x plus 9 in the denominator, 2x plus 9 times x minus 4. Do you see that? X minus 4. And the numerator we have x minus 4. They cancel out. So once we cancel them out, we get 1 over 2x plus 9. Correct? So that is the function which we have. And the domain here is, let me write down domain here. Domain is x belongs to real numbers such that x is not equal to 1, it is not equal to 4, and then it is not equal to minus 9 over 2. Is it okay? So these are the two restrictions on the given function. That is how you should be doing it. Now the next function here is f of x is square root of x plus 15, g of x is x plus 15. So f divided by g of x is indeed equal to square root of x plus 15 divided by x plus 15, right? So which I could write as 1 over square root of x plus 15. Now denominator cannot be 0 also. So in this case the domain of the function is x belongs to real numbers and x is, so minus 15 should be greater than minus 15, right? So x is greater than minus 15. Since the denominator should be greater than 0, right? The next function is f of x equals to 11 x to the power of 5. So let me write 11x to the power of 5 in the numerator, and denominator is 22x squared log of x, correct? So we can simplify this a bit. 11 goes 2 times, so we get x cubed over 2 log of x, right? So at times you can also write this as log of x squared, right? Now So let me just change this and write this as x cubed divided by log of x squared. So at times you can write it like this also, correct? But in any case, we know it cannot be 0, right? Since g of x is given to us as log of x, so we know that the domain should be, so let's write domain here. Domain is x belongs to real numbers where x is greater than 0, right? So if now in this function the denominator is 0 for x equals to 1, so we have one more answer, that is it is not equal to 1. So that is kind of important to add. I'm sorry I forgot that. So denominator cannot be 0. Log of 1 is 0, so we have one more restriction, that x has to be greater than 0 and not equal to 1. So this is kind of very critical to understand. I hope you incorporate that in your answer, otherwise you're going to lose marks. I hope that helps. Thank you and all the best.